Or was it 2 through 10 even?
1 through 9.
Odd? Cool.
There's actually none. 1 through none? Yeah, well, 0.
Alright, here we go. 2x minus 2, y equals negative 3x plus 11. Okay, so we're talking about linear equations, which are straight lines. Straight lines, if you graph them, they can cross each other, which means there's one solution where they cross, which is the x and y component. They could be parallel to each other, which means they don't cross, which means there's not a solution. And then they can be the exact same line, which means they lie on top of each other, which means there's infinite solutions. So sometimes we're going to want you to graph them, but other times we're going to want you to verify if the given point is the solution. So what we're going to do is we're going to take 3, 4, and we're going to plug it into both the equations, and we're going to see if we get true on both of them. Now, if it's true on one of them and not the other, it's not going to be the solution to the answer where it's crossed. Hey, guys, did you bring burritos?
Oh, I wish.
Oh, dang it. All right, so we're going to plug this in. So I'm going to go 4 equals 2 times 3 minus 2. And then the other one is going to be 4 equals negative 3 times 3, plus 11. Did I do? Okay. So what happened here was this. Do you agree with that? Does that make sense how I've done that? And we're just going to do the arithmetic. So nothing happens to this side. So I get 6 minus 2. I agree with that. What do you think? So I'll say yes over here. So on this one, I'm going to get 4 equals negative 9 plus 11. So 4 is equal to 2. Again, we said we didn't decipher some big mystery, finding out that one number is equal to another number now. This is absolute nonsense. That means it's not true, which means is 3, 4 the solution to this problem? No. Even though it worked on one of them, great. But it didn't work on the other problem, so it's not the solution to the problem itself. You want to break something up real quick. Let me find it real quick. I read the newspaper, which I realize I'm in the minority, but I actually do like the newspaper. I don't like the Denver Post. I think it sucks as a newspaper, but I like the whole concept of the newspaper. So let's see. This was a letter to the editor. This actually, I like this a lot. It's a letter to the editor. So Marilyn Bossavant is, as far as her IQ goes, probably one of the smartest people seriously on the planet. Like her IQ is 40 IQ points above what Einstein's was measured at. Okay? And Einstein only figured out the theory of relativity. So she writes an article in the parade section of the paper, which is a nationwide portion of it. And the question that came from this person says, do you think algebra should be required in our schools? Now, of course, your guys' opinion of that is much different than what the answer is. And her answer really does make a lot of sense when you talk about it. Of course, it works better when So, do you believe algebra should be taught in school? And it says, I believe algebra is essential. It's pure logic. And all students need to learn how to think, not just what to think. So how to think, not what to think. So Think about history. History, you're regurgitating facts, and they're saying, this is what you should think about. Math is teaching you how to think. Okay, when studying algebra, they learn to reason with facts and without bias. I'm assuming students learn why various operations should be performed, not only how to perform them, but this is a matter of how well the subject is taught, not whether it should be taught to everyone. One can't progress in most sciences without algebra, of course, but let's say we don't mind young people deciding at an early age, algebra starts in middle school, that they don't want to pursue a career that involves math concepts. Should they be allowed to skip algebra? After all, they'll use little, if any, algebraic formulas in their daily lives. No, they shouldn't. Studying algebra builds brain power. Do you go to the gym because you think you're going to use elliptical trainers or rowing machines at work? No, you go there to be more physically fit for everything you do. That's why algebra is so important for students. It helps them become intellectually fit for life. So this class, according to one of the smartest people out there, helps you become intellectually fit for life. And I've said this to you guys and girls before. Math is a way to think through problems. It's allowing you to take a large problem, break it down to small problems, and solve small problems. It allows you to take small problems and then apply it to a much larger picture. Okay, and again, the whole concept of math is the exercise in the brain, is what we're doing. It's not because you're going to go, some jobs are going to be like, hey, got two lines, they're going to cross. Tell me where they cross. It's not going to happen. But it's the exercises we do to do that. Clearing. Number 3. Oh, number 3 is interesting. We have an inequality there. Huh. How do you think an inequality is going to work with these? So they're both straight lines. Do you agree with that if I say that? Are they both straight lines? Yeah? And the only difference between the inequality versus not is a shaded region or not. So now we want to see if that point gives us a true statement with the greater than and less than. Okay? So that works this way. This is x, this is y. And I'm going to plug those values in. So I have 3 is greater than negative 2 times 2 minus 3. Then I have 3 is less than 2 times 2 plus 1. Okay, let's see. Let's do the math over here. It's going to give me, is 3 greater than negative 7? That's true. Okay, let's try this one. 3 is less than 4 plus 1. Is 3 less than 5? Yes. So, let me ask you this. Do you think that 2 comma 3 falls on either of the lines? What was it doing to fall on the lines? What was the scenario? Because this gives us a true situation, right? But does it fall on the line itself? What do you think? So in order for these to fall on the line, this would have to read like 3 equals 3. Or negative 7 equals negative 7. This just gives us a true statement. Which means if I have this graph, this is basically what this is going to look like. Something like this. Something like that. Which means that technically you have some point in there. And I'm not drawing this to scale. I'm just trying to show you how this works. So it shows that it's a true statement because of the inequality. It doesn't necessarily fall on either of the linear equations. And again, I don't know if that's how what these linear equations are going to look like. I didn't draw them to scale. I just tried to do a representation.
Wait, so isn't inequality like the dot falls not on the line? Or...
So it's So let's say I had drawn this and this, and I have shown that any of the points that I pick over in this region give me a true statement. Like, so let's say I had this point right here, I don't know, 5, 4. So if I were to plug that into that, if I plugged it in directly to find out it was equal, it's going to be false on both of these because these are equalities now. But the inequality means because this has this and this has this, or maybe going the other way, it creates a region that gives you a true solution, not an exact fixated point. Okay? So this is just 1 point. This would be like 1, 4. That would be the solution to the problem, where if I plugged it into both of the equations with an equal sign, it would be that 1 equals 1 or 7 equals 7. Not 7 is greater than 3. Make sense? Did I say that right? Okay. So the fortunate thing is you don't necessarily have to have the inequalities down. This is a little bit pushed a little further ahead. But if you were to draw 2 straight lines that were inequalities, remember the inequality when we drew it, you shaded either one side or the other? Well, that's like this. I'm going to shade this side of this and this side of this, and this is the only region that the two would share. So when you have 2 straight lines that are crossing each other, you create 4 regions. And only one of those regions will have the points in that region are true on both of the scenarios because of the inequality sign, the greater than and less than sign. So I don't think we should see that too much more. Number 5. We have y equals x plus 2. Y equals negative 2x plus 2. Okay? Take a look at that. See if you can graph it on your paper. See if you make it right. Anyone else have a test? You done yet?
Are we there yet?
Anyone else have a test beyond that? All right, what do we get? So I want these graphed. What is my y-intercept of this one? 2. 2? And so from that point, I'm going to go up 1, right 1. Do you agree?
Yeah.
Hey, is this a solid line or a dotted line? It's not an inequality, so it's got to be a... It's not an inequality, so it's got to be a solid. Cool. And then let's do this one. What's the y-intercept of this one?
2.
2. Then I have a slope down 2, right 1. Where does it appear that these two are crossing each other?
2.
No. What's the point?
0, 2.
0, 2. Thank you. Yeah, but it's crossing at 2. I understand, but where? What's the point? Where is the exact point? Okay, so if I wanted to be 100% sure that this was the actual solution to the problem, what should I do with this point? Plug it in. So that's x, that's y. Let's plug it into both. True or false? True. So it works out on this problem. Let's try it on the other one. 2 equals negative 2 times 0 plus 2. 2 equals 0 plus 2. 2 equals 2. True or false?
True.
True. So it checks out there. Is 0, 2 the solution to this problem? Yes, it is. Can I move on?
Yeah, dude. Only if you want to. You're only making us smarter. Put it that way.
Help me out. How do I graph the top line?
Cover method.
Cover. Sweet. So, what's x equal to? 4. Person who said 3, do you understand why you're incorrect? Okay, what about y equal to?
3, 4.
3. Alright. Mr. Kruger, solid or dotted?
Let's see.
It's equal.
I think it's a solid.
Yeah! Alright. So we're there. What's the y? How do I graph this one?
Go up.
2.
0, comes
And I go what?
down 1 over.
Down 1 and
Over 2 to the right.
over 2. Okay. Now watch this. From this point, I'm going to go down 1 more and over 2. So it crosses at 4, 0. How can I verify if that is correct? Sorry for interrupting your conversation. Look at it.
It's okay.
So that's x. That's y. So I'm going to get 3 times 4 plus 4 times 0. Is that equal to 12? Is 12 plus 0 equal to 12? Is 12 equal to 12? Yep, works there. Plug it into the second one. So I'm going to get 0 is equal to negative 1/2 times 4 plus 2. 0, what's half of 4? 2. What's negative half of 4? Negative 2. Is negative 2 and positive 2 combined together 0?
Yeah.
Is 0 equal 0?
Yeah.
So it works here. Is that the solution?
Yeah.
That is my solution.
Maybe.
Wait.
Maybe.
Maybe.
I don't know yet.
Not yet? All right. Number 9. Ooh, this is a tricky one. This has got one of those goofy ones.
What page are we on?
121. All right. What kind of line is that? Straight. Good.
Vertical.
Horizontal.
Horizontal.
Wow.
Horizontal.
Wow.
Everyone okay with that?
Yeah.
So that first one's a horizontal line goes right through 1.
I'm excited about it.
Mr. Kruger already answered this question. That is solid. All right. Second line is this. What's my y-intercept?
3.
Negative 3.
Negative 3. From there, I'm going to go up to right 1. Agree?
Yeah.
From there, I'm going to go up to 1, 2, right 1. Where does it appear that point is? Where does it appear this is at? 1, 2, comma, 1. How do I know if I'm right? Plug it in. Okay, the first equation. I have a point, 2, 1. I have x, y, but I have y equals 1. How do I plug 2, 1 into y equals 1? How do I plug 2, 1, Reese, into y equals 1? What? I heard it. Just the y. So this is all I'm worried about up there. So plug it in there. I get 1 equals 1. Is that true?
Yeah.
Works there. Let's plug it into the second one. So now I'm going to use both points because I have both x and y. So I'm going to get 1 equals 2 times 2 minus 3. 1 equals 4 minus 3. 1 equals 1. True or false? What can you tell me about 2 comma 1? It is the solution to the problem. Awesome. So guys and girls, I want you, please, to do 2 through 10, even, on page 121. Yes. And I am going to check this at 8:55 a.m. for points.
Wow.
Exactly.
You're good at this. For points.
For points.
Points.
More points or just for points? Wait, for actual points, not straight.
We want to take each of those points, plug it into both, yes? So that's x, y. So plug it in the top one. I'm going to get 2 times 3 minus 3 times negative 2. Is that equal to 12? Is that true or false? True. Works here. Shh. Some of you are talking too much. I'll wait. Next one. True or false? False. So it doesn't work on the second one. So is 3, negative 2 where these lines intersect? No. So is it a solution? No. Okay, problem number 4. Okay, it's goofy because we have inequality. So we're just double checking the region. So let's plug the values in. 3 is less than 2 times 2. 3 is less than or equal to 4. True or false? Is 3 less than 4? Yeah. So this gives me a true statement, which means that's in the appropriate portion of the shaded region for that one. Let's check the second one. Three plus 2 is 5 greater than 3. Yeah, that's also true. So is 2 comma 3 part of the shaded region of these two lines? Yes. And then number 6, they wanted us to graph it, find out where they cross. So plus 8, 2, 3, 4, 5, 6, 7, 8. Down 3, 1, 2, 3, right 1. That's that one. Then the second line is at 1. I'm going to go up 1, right 2. It appears that we're at maybe 2 comma 3. How could I know if that was correct? Plug it back in. If it's true on both of them, then we're in good shape. If it's not, then I drew my lines incorrectly. So I'm going to get 3 equals negative 3 times 2 plus 8. 3 is equal to negative 6 plus 8. 3 is equal to 2. What? Does that work? No. So what does that say? This line does cross somewhere around here, but I'm off on this point a little bit. Okay? So it does cross somewhere in this region. It's just that because I wasn't really neat at graphing, I was off a little bit. But hopefully that yours was a little bit better. Did someone get the solution to this? No. You get it? Okay. Sorry, I'll learn how to graph neater next time. Okay, number 8's really kind of a goofball thing. I mean, the first one's not a horrible one. I'm going to get this and then go up 3 and over 1. You missed the dot, just make the dot bigger, right? All right, and then if I do the cover method, is x is 5. And then, y equals negative 3 1/3. Negative 1, negative 2, negative 3 1/3. Oh, yuck. So it crosses about there. Do I know what's at? Again,
If we had the exact point.
did you get the exact point?
No.
Okay, but you'd be able to find it, hopefully, if you were a neater grapher than I. And then number 10, hopefully number 10 goes a little bit better than this.
Oh wait, I
Number 10, did we get a solution?
think there's no solution.
X equals 5. 1, 2, 3, 4, and 5. Y is 5. 1, 2, 3, 4, 5. Plus 3. 1, 2, 3. And then I'm going to go up 1, right 1. It looks like it's going to cross there. So that's at 1, 1, 2, 4. 1 comma 4 maybe? How can I verify? Plug it in. Okay. So that gives me 1 plus 4. Is that equal to 5?
Yes.
Works here. 4 equals negative 1 plus 3.
Oh, dang it. No solution.
There is a solution, it's just we're off a little bit. Oh. Anyone see what I did?
Oh.
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 What's wrong with the green line?
Oh.
It's cricket.
Okay, other than crooked.
It's green.
It's green. Other than green. Came here, should have went down 1, right 1. Why? Yeah, that was negative. Guys and girls, oh my goodness. These lines are parallel, so do they cross?
No.
So no solution, because they are parallel lines. Ooh, yeah, so this was wrong. I shouldn't have drawn that. Shame on me, I'll tell you. Boy, you can't take me anywhere. All right, so
Get the points.
you're in.
Yes.
They're already there.
200 million points.
It's amazing what it did to your grade.
Yes.
Finally have a D.